So here we are. We're going to kick it off, integrating building performance into your HVAC business. I'll introduce myself here. For those who don't know me, I'm Sam Myers. I'm a trainer for Retrotec. I'm a certified HERS rater. Got a few years under my belt here in the home performance industry. I've done a lot of diagnostic testing. I'm located in Raleigh, North Carolina. And before I was here with Retrotec, I was a building science specialist with an engineering firm called Advanced Energy. And I have a special guest here with me today, Mr. Steve Rardon. Steve is an HVAC contractor and home performance expert, also located near the Raleigh area. Steve, why don't you tell us about your business and how you got into this?
Hey, everybody. I don't know if expert actually makes anybody an expert, just telling them that. But I've been in the HVAC industry for almost 19 years now, and recently started my own business and wanted to focus on more than just boxes and equipment. So I integrated blower door testing, duct testing in-house for my jobs and clients as a way to provide a better value than what most other contractors that I've been familiar with are offering. So I've been in business just over a year and been offering clients a holistic view of their systems and their homes at every opportunity. It's been working out pretty well, though. Been doing a little bit of diagnostic work and testing and confirming and proving my work when I install equipment for new clients. They get a duct leakage test and airflow balancing and all the bells and whistles that come with that. And we get a chance to talk about overall home performance. But that's me in a nutshell at the moment.
So, Steve, you also have quite the YouTube following as well. You make a lot of recordings from the field, and quite a few people take a look at this and are able to benefit from it. So I think one of the unique things about some of Steve's videos that he posts online, if you haven't checked them out, is that even if he gets something wrong, he'll post it and then go back and fix it and show you, hey, this is what I did. I caught it and I fixed it here this way. So I think generally is that if he's going to make a mistake there, he'll realize that other techs are probably going to do the same thing and then show him how to fix it. So, and so Steve, you've also appeared on Brian Orr's HVAC School podcast, haven't you?
Yes, I did a podcast early on with Brian Orr, as well as Tersh Blizzett with the Business Service Mastery podcast. Service business, the name is hard to follow. But yeah, I've been on YouTube for actively since about 2014. It's been more difficult recently to actually put time into YouTube trying to operate a small business. But yeah, it's been a lot of fun. And I always figured that if I made a mistake, that it could be a learning experience for other people to see the same mistakes that they may make.
Excellent. So the way we have this webinar set up, I've got it broken up into various sections. We'll go over each one. I'll invite Steve to come in and add his feedback at the end. And whenever you want to pop in, Steve, feel free to add your input. And then halfway through, we'll stop for questions and then stop for questions again at the end.
Sounds like a plan.
Cool. Well, I think the best way to kick this off, especially for any HVAC contractors that are on and new to this sort of thing, is to talk about the house as a system approach. And so not just looking at the HVAC system itself, but the entire house and how everything works together, and looking at each component and how it all works together as one system. So that being said, aside from just the mechanical equipment, we're also looking at air tightness. We're looking at ventilation and moisture. We're looking at insulation and windows, pressure balancing. So making that helps ensure that bedrooms are going to be comfortable and have about the same pressure as the rest of the main body of the house. Looking at combustion safety, And as far as energy is concerned, lighting and appliances is also important to look at. So we'll kind of touch on this as we go, just to talk about how it all ties together. It's kind of like the human body, it's all connected. So as we're talking about home performance, HVAC equipment sizing is important to talk about. And we'll talk about how different home performance diagnostics can help you get a more accurate load count. So one thing to talk about is the blower door test. And what that measures is the tightness of the building envelope. And the way that that ties in to your load calc, if any of you are familiar with load calc software like RightSoft or Elite, you have an infiltration input. And so that's going to be envelope leakage as an input of CFM 50 or air changes per hour at 50 pascals. And we'll talk about those measurements a little more in a second. But as you can see on this diagram here, a house kind of works, the comparison I like to use is like a Weber grill. It and the heating season, it pulls air in at the bottom, exfiltrates it out through the top. So if you think about a Weber grill, you have vents at the bottom and the top. So to regulate airflow, if you close off the bottom, it's going to stop airflow at the top. So air sealing house kind of works the same way. And so this is important. So if you have a client with a really leaky house, you can get them to reduce their air leakage in their house and then reduce their load. Therefore, they need less equipment and really appreciate that input that you give them. So looking at manual J calculations, for example, if you were to go into RightSoft and look at these infiltration values that you can select, you'll see tight, semi-tight, average, semi-loose, and loose. Here's kind of what that means. So CFM is cubic feet per minute at a pressure of 50 pascals on the house. So that can be depressurizing or pressurizing. And then from a base house, this is kind of looking at it in air changes per hour. This will vary per house to house, but this is just kind of an average taken. And then when you get above 8, or if you get into 9, 10 air changes per hour, you're kind of moving away from a house to a barn. So that's getting to be a really leaky structure. So this is where you can measure leakage in an envelope and input this into your load calc and really know where you stand to really get that size correct. And a lot of times the question is asked, when is a house too tight? Well, I mean, my answer to that is you can't get a house too tight. The question is, when do I want to add mechanical ventilation? And I like to say around 5 air changes per hour. When you start getting below 5 air changes per hour, that's getting the house relatively tight. If it were my house, I would want to pull in some outdoor air and filter it. And we also get the question of, who can perform a blower door test? Really, it's anybody really. And if you're doing it to code, in some states, the HVAC contractor is allowed to do this. They're certified to do this test. So, like for example, Florida, this is required for residential new construction, and so blower door testing is a new service that a lot of HVAC techs are starting to offer. Steve, what did I miss here?
I don't think you missed anything. I think the only person that you missed on anyone would actually be homeowners that are willing to either rent or invest in something to be able to take these readings. A zonal pressure test can be massively important and can be done by a client with a simple gauge to be able to see where they have pressure imbalance specifically.
Exactly. Great. So we'll dive in a little deeper here to talk more about envelope air tightness and just, some pictures from the field and just to really show what it is we're talking about for those of you that are completely new to this. And so when we look at envelope tightness, really the 4 things that we're looking at are energy, comfort, air quality, and durability. High air leakage through a structure can have a negative effect on all of these. As you know, as you get more outdoor air coming in, that's the harder that system has to work, makes you more uncomfortable, decreases the quality of the air that you're breathing. You're bringing in all kinds of pollutants from the outdoors. And of course, durability problems, especially in the kind of climate that Steve and I live in here in the Southeast. if you have, condensation issues within a wall assembly, that can cause framing members to rot down the road and cause some durability issues there. So when we're talking about tightness, when we're talking about leakiness, one thing that we have to define on a house is, where is that air barrier? And so if you're working with new construction, or if you have plans, this is really easy to draw out, but for existing homes, you don't always have that luxury. But for the purposes of this talk, this is kind of what we're talking about here. This is really where you define inside versus outside. Notice that we don't have the garage in here because that's not conditioned space, or we're going to call that outside. So you really want to go ahead and define where that air barrier is going to be on the house. It's also helpful to have a view from the elevation perspective as well, especially on some more complex houses where you have attic space that's adjacent to conditioned space like this. This is what causes a lot of leaks in some houses that are built this way. A lot of times, outdoor air will leak into this wall here from the outside. A lot of time there's no bottom to this wall really. It just openly connects to the floor space below, which can cause air to leak in here. And then same for basements and crawl spaces. You got to figure out where that air barrier is going to be as well. Is this basement conditioned or not? Should the air barrier be here at the bottom, or should it come across this way? So same for crawl spaces. If it's encapsulated, maybe the air barrier will come all the way down and all the way across the ground. So it's important to really walk the house and get a feel for it, and really see how air is working in that structure. So if you're working with a builder or an owner that's having new construction, one thing you want to do is kind of walk through and look for some of these problems before they start insulating and sealing things up and hanging the wall. So you'll see some penetrations for plumbing, electrical, penetrations through sheathing here. You can see anywhere you can walk through and see daylight. That's really an area that you're going to want to recommend that they seal up. So stud packs, things like that, that's areas where that house is going to leak. And so even for existing homes, one of the biggest culprits is going to be in the attic. And so that's where sealing is going to, or where your drywall is going to butt up the top plates. So this is in an attic looking straight down at a top plate. So you can have air leaking in here and here on both sides of the wall. And that's for interior and exterior walls. So if you think about it, for a lot of houses, that adds up to be quite a big hole. And the way you fix that is you can take some caulk or some spray foam like this and really go around each of those and make sure it's nice and tight. Same for chases. We have an uncapped chase right here. So that's kind of like having a window open at all times in the worst possible place of the house. So whether it's new construction or existing homes, you can cap that and then seal these edges here with some caulk or spray foam. And then corners are also weak spots. Anytime you have one material butting up to another, you want to seal that seam. So here on this corner where they missed, you would want to seal this stud to this piece of sheathing here. And this is a 2-stud corner, and so you would also want to go behind this stud and seal that one as well. Windows are also important. They used a low expansion foam here on this detail, so they could get a nice seal around this window. So for new construction, that's something that you want to see. If you're working with an existing home and they're going to replace the windows, this is something that you can recommend to help reduce that load. And then other areas too are around penetrations that you have in the ceiling. So this is a return in a ceiling, and this gap right here is pretty crucial because as that return kicks on, it's going to suck in air out of the attic space. And then any other kind of penetrations that you have too, such as this can light. This is one of those supposedly airtight can lights, but if you don't seal around that connection at the bottom, it's not going to be all that airtight. Steve, what are some of the things that you've seen on construction if you've gone into the house that you've recommended that homeowners or builders integrate to improve performance?
I haven't had a significant amount of work in that regard. But what I'm seeing is exactly what you're talking about, where you want to make sure that your bath fans are sealed into the sheetrock. Like the return, when that bath fan kicks on, it has a potential to, cause leakage there, or simply leak even when it's not on. So the returns, the can lights, outlets and fixtures, top plates are an easy one. Generally speaking, those are accessible from the attic space. And so, those are all low-hanging fruit, if you will.
Right on. So we'll move on to the next section. As I talked about earlier, as you get houses tighter, one thing that you want to add into that is mechanical ventilation. So as we seal up all of these holes in the building envelope, the house no longer has that natural ventilation that it's had before. You're cutting that off. And so now you want to bring that in someplace else. So now you have full control of how that house is going to ventilate, and then you can filter it where that air comes in. So that really improves not only energy efficiency and comfort, but indoor air quality as well. So some of the common things that you see are really a damper, a motorized damper that has a timer on a switch. A lot of times this is tied into the return somehow, so it could tie into a return box and then filtered here on the spot. You'd have this damper somewhere on the line, and it's bringing outdoor air in and then filtering it before it hits the return. This is kind of an example of how, not my favorite example, I don't really like how this juts out into the return here, but you can kind of see what I'm talking about. This is the ventilation being tied in here. Typically, the way I would recommend them fix this is I would like a taller return box and have them put it in the side so you don't have this going on. But this is just an example of how that would work with a 12 by 12 filter. And then with whole house ventilation, there's more than one way to skin a cat. This is an ERV, and basically what this does, it's a standalone system that pulls in air from the outside and pumps it in, and then brings stale air from the inside and moves it out. ERVs are really good for humid areas. They don't dehumidify, but they help remove some of that moisture that's coming in. So they don't pull moisture from the inside. They kind of help remove that moisture coming in from the outside as that air is coming in. And that stands for energy recovery ventilator. You also have HRVs, which are heat recovery ventilators, but they usually don't have this moisture removal process coming from that incoming, being removed from that incoming air. And then another thing that we're starting to see in this area too, you have ventilating dehumidifiers. So adding a dehumidifier to your HVAC system is kind of an easy fix to help remove humidity problems. But this company, Ultra Air, they have a ventilating dehumidifier, so you can kill two birds with one stone. So Steve, how have you seen whole house ventilation? Have you seen a lot of your customers becoming more educated on it? Because I know as we're reducing air leakage to the house, it's necessary. So what's one way that you're being able to educate some of your customers on that?
The way that I'm trying to educate is that infiltration leakage obviously is not controlled. You get the house. There was a question in the questions that said, would you recommend against mechanical ventilation if the house doesn't meet the ACH levels? And so it's not a matter of recommending against it, but it's a matter of thinking about controlling your infiltration versus uncontrolled infiltration, which can cause problems. So leaking air is expensive air, where if you control it, it's much less expensive to address that leakage.
Yeah, that's an excellent point. And I think another thing to mention too is that even if you don't have any fans running at all in the house, if it's just sitting still and no wind blowing, you still have air leaking through what's called the stack effect. And that's kind of what I was talking about earlier. As leaks come in from the bottom and then exfiltrate through the top, air is always coming in and moving out. So that's just going to make that system work harder. But yeah, so the best way to know if you really need that or how much you need, you got to do a blower door test to see where you stand. And so speaking of the blower door test, we'll talk a little bit about that, what it looks like, how it works, just the basic mechanics of it. So this is the Retrotec blower door, and as we're looking at this, this is set up as if we are on the inside of the house and we are setting this up in an exterior doorway. And so what we're looking at here, this is the inlet of the fan, and so this is blowing air out. And so it's set up to depressurize the house. And the way this works is we have 4 sensors here that measure fan pressure. The gauge here at the top knows the opening of the fan. And so as air is collected here, it's moved to this hose port, that's this yellow one here, which then goes to the gauge. So the gauge is always knowing what's going on with this fan. And so since we can measure pressure at the fan and we have a known opening, we can calculate flow. And so the gauge automatically does that on its own. And so with Retrotec blower doors, the gauge is kind of the brain and controls of the whole assembly. There's a data cable that plugs in from the gauge to the fan. And so once you set your pressure, it runs the fan automatically by itself. And then as we'll look at some of the other pictures later on, you'll see there's some red rings that go in here. And so you can reduce your inlet size of the fan to increase pressure inside. So that way the gauge can always take a reading. So this is just a closer look up here on the center of that fan where those ports are, where that air is collected. And so as we do this on a house, we would, like I said, we would set it up on an exterior doorway. And on most residential houses, what we would do, what we call a single point test, and that's just depressurizing the house to a single pressure. And for residential homes, we do 50 pascals. And so inside of this house, we would have 0 outside. We would have a hose coming out to measure that 0. And so that way we would be reading -50 inside, which means around the exterior border, we would have a +50. That's where we can see that air moving in. So basically the blower door is just exaggerating that infiltration so that we can measure it at a certain point. And so one thing to think about is when we're doing a blower door test and thinking about that air barrier, the duct system, if it's in the attic or a crawl space, that duct system is actually part of the air barrier. And so as we're doing a blower door test, if there's any leaks in the ducts, it's picking that up. Same for can lights and any kind of electrical boxes up in the ceiling. And so I mentioned depressurization tests. So that's where we are blowing air outward outside of the house to pull infiltration in. We can also do a pressurization test where we flip the fan around and we pump air into the house. I recommend, if you have the choice, to do a depressurization test instead, because with pressurization, you can blow open dampers and things like that. And if you're doing like an energy rating or something like that, those stuff you're really not allowed to tape off. So doing a depressurization test, I think a lot of times gives you a more realistic number. So that's kind of the basic mechanics of what a blower door is and how it works. And that's how that tool gives you that infiltration number. So with homes, you're looking at a certain leakage at 50 pascals of pressure. So now you have your measurement, you know how leaky the house is. So now what? So now the next step is, if you want to locate where those leaks are, where the homeowner can really spend their money wisely to see how to reduce that leakage number, here are some methods that we're going to go into to look at to be able to accomplish that. So one method is the pressure pan test. So a pressure pan is this red pan right here that has a rubber seal on the bottom. It has a port that you plug in a tube that then plugs into the gauge. And this is the same gauge that you would use with your blower door or a duct tester. And so you would go around the house with your blower door running, again, depressurizing the house to 50 pascals. and then going around with this pressure pan, and you can actually locate where some duct leakage is by applying that plan over returns and then over supplies as well. And there's not really a certain number that you're looking for. You're just looking for differences. So if you're going along a duct system and then you notice one is significantly higher, that's the branch that you're going to want to focus on when you're going to seal ducts. And so here's just another drawing of kind of how that works. So to use a pressure pan to locate duct leakage. So for example, if we were noticing that this branch here was reading 6.8 pascals of pressure, and this one was 1.1 pascals of pressure, then there's kind of a big difference there. And so that other one would be a little bit leakier than this one here. So again, there's not really a specific number you're looking for. You're just looking for differences. And then on top of that, not only ductwork, you can find leaks in the house as well. So as this person's doing here, you can put it over any penetration you have in walls, whether it's exterior or interior walls. It can be switch boxes, outlets, anything that made a hole in that wall. You can measure to see how leaky that wall is. And so the way this works is you're depressuring the house to -50. And then if they're getting this reading of 35 positive, then that means half of the air that's coming into this wall assembly is connected to the outside. So that's going to be a really leaky wall. And so that can tell you, pinpoint to where part of that problem is. Is it coming from the attic? Is it directly outside? Is it coming from the crawl space? So that can really tell you what part of the house is having those issues. And then aside from pressure pan testing, you can also do smoke testing. And what we use now isn't actually smoke. We used to use smoke. It's an item that you can light. I know a lot of people still use those today. But one thing that's kind of popular now is this Tiny S smoke generator. And this is basically a handheld fog machine. It comes with rechargeable batteries. It has cartridges you can refill. It's a glycol solution, so it's okay to breathe in. It doesn't corrode metal. And I've got a quick video to show how this will work. This is a house that I looked at a couple of weeks ago, doing some pressure pan tests and some smoke tests to identify where some leaks were. Here I'll show a few clips on how you can use smoke emitters, such as the Tiny S handheld fog machine, to locate leaks in building enclosures and HVAC duct systems and air handlers. Basically what this is, it's a handheld fog machine that puts out a nice vapor that behaves a lot like a smoke. It's a glycol solution, so it's safe to breathe in, safe to put on metal, doesn't corrode. Comes with 2 rechargeable batteries. For this particular house, we are pressurizing the house with a blower door, so we're bringing air from the outside and pumping it in, and air is leaking out through holes in the enclosure. So as we see here, we're putting the smoke to the supply, and we can see a lot of smoke going into that. So we can see that there's a massive leak somewhere in this branch. Later, we find out that the duct is completely disconnected thanks to a family of cats. So this one's down in the crawl space. So one example of how you can use smoke to find leaks in the duct system right off the bat. Still pressurizing the house, we've moved up to the attic, and we are at this can light. So air is being pushed out of that can light assembly and pushing that smoke away, so we can see that that's a pretty major leak there in the ceiling.
And here we've noticed a leak here at the window. It was really hard to miss because with the blower door running to positively pressurize the house, it's actually making a really high-pitched hum. So along with that hum, you can see how the smoke is escaping to the outside through the leak there in the window. So we can tell these windows never got sealed when they were installed. Here's an attic access door built into a knee wall, and this leads into the attic space adjacent to this room. And so with the blower door still running to pressurize, you can see the smoke escaping the room through the crack at the door. Some weather stripping on this door would help prevent this.
So looking at duct systems, we are pressurizing this duct system with the Retrotec duct tester. And here we're looking at some penetrations in the air handler where that can be sealed to make the system more efficient and to keep air from leaking out. You can see how the smoke is interacting there, along with these punch outs here on the side too. These are usually sources of leaks as well. So you can see the air getting pushed out of that air handler, interacting with that smoke, showing us that we have a leak. In addition to smoke testing, using a pressure pan is also a great way to locate leaks. You would use this with the same DM32 gauge that comes with a blower door or Retrotec duct tester. So in this scenario, we'll do the opposite of what we were doing earlier. This time we'll depressurize the house and pull air into the house through leaks in the enclosure. So here you can see I have my gauge hooked up to the blue port where the other end is attached to the pressure pan. And we're going to look at that same supply that we looked at earlier with the Tiny S smoker. So still depressurizing the house to negative 50 pascals. What we're seeing here is a positive 50 pascals on the gauge, which means that that part of the house is completely connected to the outside because of that disconnected duct. You can also use a pressure pan to measure leaks in other parts of the building enclosure as well. Here we have an intercom system on an interior wall, and we are getting a measurement of about 37 pascals. Since we're depressurizing to negative 50 pascals, this pressure differential tells us that over half of this wall cavity is connected to the outside. For this instance, this is particularly due to leaky knee walls in the attic that is moving into the interior wall space. These are just a few of the various methods you can use to find leaks in building enclosures and HVAC systems. To learn more, visit Retrotec's website or YouTube page. But basically, that was just a video of a house that I tested out a little while back just to show how this kind of stuff works and how you can locate issues with smoke and with pressure pans. And so, in addition to that, too, another tool that we use to locate some problems in houses and HVAC systems are thermal imaging cameras. And so, there's actually one out now by FLIR. It's called the FLIR One that you can plug into a smartphone or a tablet. It's about $400. It's not the resolution that you would get from a high-end camera, but using it with the blower door is really nice because you can exaggerate those leaks coming in if you have a good delta T between inside and outside. And you can go around and really see what you couldn't see with the naked eye. So we'll take a look at how thermal imaging can help you find those kinds of problems. So this is a thermal image of a door that was taken at several different pressures while the blower door was running. So we can see negative 5 pascals, negative 10, negative 25, and 50, and how that leakage changes as you increase pressure. And so when you're looking at a thermal image of leaks with the blower door, it's always handy to see how much that blower door was depressurizing. And so one thing to think about when you're doing this is you don't want to just go ahead and ramp it up to 50 pascals because once you've done that, you can't really go back and see what it would have been at a lower pressure. So you want to start low and work your way up. Again, similar image looking at an outlet on an exterior wall here. You can see as that leakage goes up, as the pressure goes up. So some leakage here underneath coming up under a floor heater. Some leakage here at a corner. Like I mentioned earlier, corners are weak spots. So you can see here, there's definitely some cold air coming into this wall. This is on an attic knee wall. So attic knee walls can be particularly leaky because a lot of times there's no rigid backing on the back side of that wall. It's just attic air coming in. We can see with the blower door running here at negative 15 pascals, we can see some warm air coming in here. This is probably in the summer. And it looks like there's also some insulation missing here on the ceiling. So it can help you find gaps and or the non-existence of insulation in some cases. As Steve and I were talking about earlier, having return boxes and bath fans sealed, this is a grill that was not sealed to the drywall, and so we can see some leakage there as well. An IR camera can also show you how your throw is doing on certain supplies. So on this toe kick, we can see that a lot of the heat is coming straight out of this. So you can see how that heat is coming out of that grill. In some cases, thermal imaging can also help you find duct leaks. So where a lot of this heat should be going into the main living space, you see a lot of this still hanging out here in this basement, where it's not getting to its intended destination. And then I can also help you look at outdoor equipment to see how things are performing. If motors are too hot, or these fins, if they get smushed down, how that's affecting the compressor unit outside. Various things that you can find. And you can also find clogs in plumbing as well sometimes as well, especially if you put some hot water down, you can see where that temperature changes if there's a clog and a P-trap. And electrical issues as well. If the breaker's too hot or if an outlet's too hot, you can easily find that without having to plug anything in. It just shows right up. So Steve, I think you do some thermal imaging, don't you?
Yeah, thermal imaging is probably my biggest geek point beyond doing a blower door in the first place, because it is so varied in its uses with duct leakage and everything else. You can have a client that complains that the breaker trips randomly, and you go there and test it and you don't see anything wrong with the equipment. But if that terminal at the panel is loose, you'll get the picture like we've got on here, where the breaker is showing up hotter than normal. So yeah, a couple $100 for a FLIR 1 or something similar is definitely a very good investment for an HVAC contractor trying to be more holistic.
Gotcha. We'll move on to our next section here. We've been talking a lot about the building envelope and finding leaks there, but finding leaks in the duct system is also important. And so we'll talk about some methods for that. So to measure leakage in a duct system, you'll need a duct tester. And so Retrotec makes one for residential and commercial. And so setting this up, you would tie this on. Typically, this is tied onto the return. Well, first, let's talk about, let me talk a little bit more about the system before we get into some leaks. So typically, you would tie this onto the return, and then you would tape off your supplies, and then you would have one more tube coming out of one of your supplies to plug back into the gauge to read the pressure in the duct system. And so similar to a blower door, this is going to pressurize or depressurize that duct system. Instead of 50 pascals, you're going to do 25 pascals. So a similar process, just with a smaller fan. And so as we're looking at duct systems, some common leaks, basically at different connections here. So we can see this supply boot here is starting to tear. This flex is tearing here, so that's a massive leak right there. This connection here just never got sealed, so that's going to leak a lot of air as well.
They must have cut that one with a butter knife.
Yeah, that's not looking too good. And then looking at supplies in the floor, there's, as we were talking about ceilings earlier, but there's also leakage between the floor assembly and supplies as well if you have your duct system in a crawl or in a floor space below. So you want to use some caulk or mastic to seal that gap around. And so looking back at supply boots in the ceiling, as we were talking about earlier, one of the critical points is sealing the supply boot to the ceiling drywall. And so usually a lot of mastic here is a good sign. It looks like they sealed up all their seams pretty well there. And then on the finished product, if we were to take those grills off, there's still a massive gap right here. And so that's the kind of stuff you want to seal up, because that's a major leak there, just not for the ducts, but for the envelope. So that's kind of a double whammy. And then looking at some other locations too, around the air handler is always going to be some leaks that you can find where you have dissimilar materials or parts meeting that didn't get mastic put over them. And then this kind of duct tape on a system is never really a good sign. Duct tape is usually one of the worst things you can use on ducts to seal leaks. So a good coat of mastic is always going to be your best friend there. And then pan ducts are also kind of a nightmare for leaks, where you're actually using the framing of the structure as part of the ductwork. And here there's a piece of plumbing going up, so that's never want to see that. So this kind of assembly here, I always like to try to avoid, because it's nearly impossible to get a good seal on it, especially when you have something crazy like this happening. So going back to setting up a duct tester, you would have a kind of tape like this. This is called duct mask. So this is safe to put on drywall. You can just slap it up over the supply and the returns, and it won't take the paint off. And then, like I was saying earlier, you want to have a tube that goes up through one of the supplies. Usually the supply closest to the air handler is going to be the best one to use. That way you can have a probe in there that's going to measure the pressure in the duct system with respect to pressure in the house. And there's other options instead of using tape. There's the vent cap system and duct block. Both of these are just a temporary seal that you can use to put a cap over supplies if you don't want to use tape. But attaching the duct tester up to a return, Retrotec's duct tester comes with this clear flange, and it has two hooks in it that hooks into most return grills. So the most common ones you see out there, it'll hook right in. That way, if you have a return in the ceiling, you're not having to fight gravity and tape that thing on there. It'll hook itself to it, and then you can take your duct mask tape and then tape to this flange to finish taping off that return. So similar to testing air leakage in a house, I recommend doing a depressurization test on ducts. That way you're sealing that tape tight up against that supply. Flipping around and pressurizing it sometimes can blow that off and make this test really difficult. Another thing to remember when you're doing this is, if this is a finished house, open up a window, because you want to get a good balance between outside and inside air. So you want to make sure a window or a door is open when you do this, just so that you don't have any kind of funky readings. So this is kind of the general idea of what we're talking about. You can also hook one of these up to an air handler if you don't have a good return that's going to fit. So you can do that as well. So there's a couple of different ways you can do it. So this is just a little schematic to show that on Retrotec, everything's color coded. You just your blue hose will go to your ducts, and then you have two other hoses that go to your fan. Just yellow goes to yellow, green goes to green, and then like the blower door, there's going to be this data cable that hooks into the fan. So that way you can control everything from the gauge. And again, we depressurize and pressurize ducts to -25 or +25 pascals. And I also like to depressurize too, and I'm looking for leaks in ducts with a smoker. That way, it's a lot easier to watch that smoke disappear into the duct system rather than watching it blow back at you. And then the way you calculate your leakage, it depends on you look at this number based on the square footage of the home. And so if this is a 2,400 square foot home and you do your test at 25 pascals and you get 140, so now you're looking at 5.8 CFM per 100 square feet. So that just kind of gives you an idea of what that leakage is. So your reading is always going to be a reading in CFM. And you can also use a duct tester in combination with a blower door to find just the leakage, duct leakage to the outdoors. So if you're only caring about leakage that goes, if you don't care if it's leaking inside the conditioned space, if you just want to weed out that leakage that's going to the outside, you can do that as well by setting up a blower door to also depressurize the house to -25 pascals. So that way you have the house pressure and the duct pressure the same. So the only leakage that you're reading is that leakage to the outside. So you can separate the two.
That's one of my favorite combination tests to do, because in North Carolina especially, and climates where your equipment is outside your house, duct leakage can be, insignificant if it leaks into the house, but if all of your ducts and all connections are on the envelope air barrier, duct leakage to outside is actually what matters. And then I had a lot of fun making a video recently where I used 2 blower doors to do sort of a Frankenstein test to figure out specific leakage in a zone with depressurizing the master suite at my house and depressurizing the house to figure out specific CFM loss in my master suite. That was a lot of fun.
Yeah, so for that, you set up a blower door just like you would in an exterior doorway, and then you put another blower door system in the bedroom doorway, right?
Yeah.
So that canceled out all the leakage so that all you were seeing was leakage in that master suite. So you could just focus on one room at a time.
Yeah.
That's not a common test. When I first met Steve, he was like, have you ever done this? Like, no, I haven't. Let me know how it goes. But it's a really good way to separate things out. So using 2 fans at once, you can cancel some things out to really see where leakage is. And if you're doing a leakage to outdoors test like this, just because all the ductwork is inside the envelope doesn't mean there's not going to be any leakage to the outside. You can have duct leakage leaking out to the outside through leaks in the envelope. So that's another way to kind of give you, if you're not going to do a full blower door test, you can see, well, maybe this is a really leaky house if I'm having that much duct leakage to the outside. So it's another way just to kind of get a feel of the house and how it's performing. So the next thing we'll look at are just some apps that you can also use with some of this type of equipment. One we have is an automated testing app called rCloud, and this is something that you can use on your phone or your tablet. These gauges that come with your blower door and your duct tester, they put off a Wi-Fi signal that you can pair with your device. And so with this, it'll geolocate where you are. It'll automatically put in outdoor weather data. It'll find the house on Zillow. If it's a brand new house and it's not in Zillow's database, you can just click new construction and enter some characteristics of the house there. And then once you have all that filled out, you can go ahead and run, whether if it's a blower door or a duct test, it'll run it automatically and give you this really nice report at the end to tell you what all the conditions were, what your leakage number was. If you needed to pass a certain number, it'll tell you if you passed or failed. But with the geolocating, it's really nice. It'll put this picture of the map of where you are on the report. For this particular house, it did not do that, but for some of these, this is what it will look like on the report. And if you wanted to pass a certain ACH, so if you had a target of like 5 ACH 50 and it got under that, it'll tell you pass. If it was higher, it'll tell you you failed. So right there at the top, this is nice to leave to building officials. It's nice to leave with homeowners or developers, whoever you're doing the test for. And it saves it securely on a server on the cloud. I think, Steve, you've played with this a little bit, haven't you?
Yeah, I've really enjoyed the rCloud app. A lot of contractors around me will do a handwritten pass-fail report, and I feel like the rCloud definitely gives that legitimacy to the whole process to where, you can't fudge the numbers, at least what the gauge puts out. So your client can be confident that you've got, true numbers and equations done with a pass or fail.
Gotcha. Yeah, and you don't have to write anything down. It's all there for you. And like Steve said, you can't really fudge it. It is what it is. So it really gives you that accuracy.
The only thing you might be able to fudge is square footage, but then you'd have that recorded and could be caught by paying attention. So
sure,
if you did fake it, it would be traceable.
Yeah, if you refer back to the plans and it doesn't add up, then yes, I'm sure some questions would be asked. So another app that will work with your gauge is called the Gauge Remote app. And this one's pretty simple. Basically what this does is it mirrors the screen on your gauge onto your device. So that way you can walk away from your fan that you're running, whether it's a blower door or a duct test. I like to use this if I'm looking for leaks in ductwork, especially if my air handler is up in an attic or down in a crawl space. That way I don't have to keep running up and down a ladder or running inside or have to depend on another person to change the fan speed. I can control this from anywhere in the house and have my phone in one hand and have a smoker in the other, or an infrared camera in the other, whatever other tool I want to use with my equipment. It just really frees you up and allows you to work a lot faster. And we have a similar program that you can use on your PC as well, where you can pull your gauge up on a laptop and do this. This is really good for training. So if you're training other people like this guy's doing here, you can blow it up really big on a projector and go through and explain how it works. Sometimes it's fun to run a test like this with a homeowner, having this big on your laptop and explaining, what all these numbers mean, to blow it up nice and big. Well, so let's stop here for a second and look for any questions that we have coming in.
Okay. So we actually have a few here.
Okay.
Let's see, Thomas was asking, in his area, they see significant leaks around fireplaces, even with the flue being closed, and then same thing on the kitchen exhaust dampers. Is that a common issue that you guys see as well?
Steve, yeah, I'll let you answer.
Yeah, fireplaces are, I don't know, one of the worst things that a house can have inside when it comes to trying to maintain leakage, because you can't have components in that fire damper or draft damper that are combustible. And so if you've got a cast iron fire damper, you know that cast iron to cast iron is not going to be airtight at all. And as they get old, even if they did have some fire retardant component in that damper assembly, that is going to be one of the first things that rots away based on all of the fumes that go up the fireplace. So if you have fireplaces that aren't being used, the best thing to do would be to block that off as permanently or as completely as possible. That may be reversible if someone ever wanted to use the fireplace again.
And just to add one quick thing onto that, that does not necessarily mean that you can temporarily seal those for the blower door test.
No, you shouldn't do that. You want to include that because that's part of the leakage going on in the house.
Right, should be representative of the normal conditions.
Right.
The next question.
Well, before we move on to that, one thing I like to do with fireplaces is look at it from the attic side to see where that chimney assembly is penetrating through the air barrier. A lot of time that's a really leaky area there too, not just in the damper, but around the exterior of the chimney. So that can really be a leaky spot as well.
Absolutely.
So similar to that leakage and whether or not you can seal it, Mike was asking if intentionally designed ventilation or mechanical ventilation should or can be sealed before you do the air permeability test.
It depends on what type of ventilation you have. If you have a motorized damper that's going to be powered shut, usually that damper is going to be closed. If you have a damper that's not motorized and is just hanging out there, then you gotta leave that open. But a lot of times that damper is going to be closed. And if you're using an ERV or an HRV, you'll leave those alone as well. Steve, did I miss anything? What are your thoughts?
That would be where you would consider a positive and a negative pressure test for comparisons, because you know that you're going to have draft dampers blow open on bath fans and kitchen exhausts if you're doing a positive pressure. So to get a more holistic picture of the leakage, you would do positive and negative or negative and positive to confirm. And it's so simple. You literally flip the gauge around and turn it on again and reach pressure. And that may not tell you where it is exactly, but at least you know that you've got some mechanical ventilation that is not sealed in one pressure direction or another. Right.
But yeah, that's a great point too, is looking at it in both directions. But I would not tape it off. For the majority of it.
That would be tantamount to falsifying a report.
Yep.
Okay.
Cool.
Looks like the other question was answered in chat, just about explaining the duct leakage duct leakage per floor area result and what that represents. I didn't know if you wanted to go over that again as well.
Yeah, just looking at duct leakage, it's a percent of the floor area served by the system. So if you have a house with two systems in it, you'll measure them together. You're just looking at the total floor area of the house, and then sometimes you'll have a target. So if you're doing for code and they have a requirement that it cannot be above 6 CFM per 100 square feet. I mean, the same way you can look at that, it's 6% of, or you can take 6% of the total floor area, and that's your target. And so that's the number you don't want to go over. But yeah, it's an easy calculation. You can just bust out your smartphone and just say, this number times 0.06, or just if you're doing it for code that way. So I had one program that I used to work with where the target was 3%. So that was getting pretty tight. But it's just whatever your floor area is of the house, that's really all what you need to look at to reference.
And the idea being is you're normalizing that result so you can compare it to any other system based on the floor area and the leakage.
Okay, yeah, gotcha.
Yeah, I think that was it for questions. Nothing here, at least. Nothing else on the panel.
Okay. Steve, did you have any more input on any of that?
No, I think that was well explained.
Great. I have one more quick section here, talking about the DM32 gauge used separately. So we've been talking about how you can use it to run a blower door and how you can use it to run a duct tester, but you can really pop this thing off and use it as a manometer for anywhere a manometer is used. And this is especially good because this gauge, to be able to run a blower door and a duct tester, it has to be accurate within a fraction of a Pascal. And so if you remember, there's 250 pascals in 1 inch of water column. And so that's getting really, really, really accurate compared to a lot of other manometers that are out there that are used in the HVAC field. So for example here, any of you know who Corbett Lunsford is? He has a really good video on YouTube of how you can take total external static pressure using this gauge. And essentially what the DM32 gauge is, it's two manometers built in one. It's called a two-channel manometer. It has two different sides. And so you can take multiple measurements at one time, and then get a really, really accurate answer to see what's going on with that system. And I definitely recommend checking out some of his videos online as well too. He gets really into the weeds on some different diagnostics. But
he does a really good job of keeping it where it's easy to be understood. So even if you don't test, static pressure on an HVAC system, you could take his video and replicate the test with a high probability of understanding what you're doing.
Right. And then another thing you can do to look at some comfort items inside of a home, you can just look at what the general house pressure is telling you. So if you aren't hooked up to any equipment, you have the doors shut, you have the system running, the house is running naturally, you can take a hose and run to the outside underneath a door. Gauge comes with this hard tube, and these get bent up and beat up pretty quick, so you can get these at a hardware store or whatever. But just hook the tube onto that and shut the door under it, and then just let the system run and see what pressure the house is under. So for example, my house is a little positive. So what does that tell us? It could be that I have more leaks in my return than I do on the supply. So that return is picking up outside air and dumping it in, giving my house a positive pressure. So just by doing that, it can kind of give you an idea of where the house stands. And you have to excuse my dog here. He's really intrigued by what I was doing. So just little things like that can kind of give you an idea of what's going on in the house. It's also good for balancing bedrooms. So a lot of high performance home standards say that to ensure comfort inside a bedroom with the door shut, there shouldn't be any more of a difference between the bedroom and the main body of the house than 3 pascals. So by doing that, all you do is you take that same tube, shut all the doors in the house, let the system run, go into a bedroom, shut the door behind you, and look and see what that pressure differential is inside that bedroom versus the rest of the house. So that can kind of help you, along with testing airflows or the flow hood or something like that. You can also, pressure test the bedrooms and just kind of see how it's behaving. Steve, what are your thoughts on this? Is this something that you usually incorporate?
Yeah, I had not incorporated the HVAC as a pressure system until recently, but it gives you a basic, simply running your HVAC system and doing a zonal pressure test can give you a lot of feedback on whether or not that room is under or overserved, which can be the answer to some of your comfort issues if the room's hot or cold, depending on the season. It's a very simple one, once again, homeowner capacity. Depending on the accuracy of the gauge, depends on how accurate it is, but they could do it with a very inexpensive pressure gauge, even if it's not, hundredths of a Pascal.
Gotcha. Cool. And I forgot I do have another little section here just about some tips for communicating with clients. I know a lot of times when we come onto a site, communication is important. And I read a quote not too long ago is that the biggest problem that we run into is that we don't listen to understand, we listen to reply. And so a lot of times we want to go ahead and give our input there on the spot. And we tend to step over what the client's problems are and just try to go ahead and get to that issue really fast, which can be a mistake because a lot of times our clients can tell us things that our diagnostics can't. And so just a few communication tips. This is from a webinar we gave a while back, but I thought it was kind of fitting for the HVAC industry. A lot of times in business, the deal is made there at the kitchen table. So a lot of the active listening questions that I like to ask, or a lot of the things that I like to talk to back when I did consulting on behalf of some utility providers is, ask them to tell you as much as you can about the issue. Is there anything specific? Has it caused any health problems? Has it affected how they sleep? Has anybody tried to correct something? Has anything major happened to the house since this has happened? For example, I had somebody call in and they were having all of these moisture and mold problems and neglected to tell me that they had the entire HVAC system replaced. Well, that older HVAC system was probably doing a better job dehumidifying the house than the new one was. And so a lot of things had to go in there. And so actually doing some air sealing on the building enclosure helped remove that because less moisture was coming in to condense against different parts of the wall. So it's important to ask these different questions and just really sit down and talk with them for a while and be really casual about it and just really be an active listener instead of trying to dive into the issue. And I think that's one thing that Steve does too that separates him apart from others, especially as he takes the time to make these videos to show other techs different ways to solve different problems. And so that kind of takes me to my next part is, Steve, how has this kind of thing set you apart from others? How has it really affected your business since you really started looking at the house as a whole instead of just the system?
Generally speaking, it has actually allowed for a higher ticket margin because you're offering a service that other HVAC box swappers are not paying any attention to. Majority of HVAC companies that I've dealt with or been familiar with are tunnel vision on the refrigerant pipes and the two ends of it. And by making it a conversation with the customer about their issues, you open up the opportunity to sell more service. And it doesn't have to be a bait and switch situation or a squeeze this extra service in. It's a matter of educating the client on what is going on and the things that they have available to understand when they don't know that it's there, that allows you to, have a higher margin on your projects.
Yeah, that's a great way to put it. And, I think you were telling me a little while back too, is that you really don't do any marketing, do you? It's since you've been able to incorporate this, you've had a lot of good feedback from some of your clients, and so a lot of it's just since then has been word of mouth, right? Yeah,
the majority of my work has been word of mouth, despite my attempts to do marketing. None of my marketing has actually come back to pay me. It's all been referral based. So it's been a blessing and a curse at the same time. I just had a client that scheduled an appointment tomorrow for service when he found my YouTube channel. So, it comes from more than what I've specifically tried to do marketing the company.
Gotcha. Lee, do we have, we're kind of reaching the end here. Do we have any more questions that came into the box?
It does not look like it.
Okay, great. Well, Steve, any final remarks?
No, I think that if you are an HVAC contractor and you're checking out the opportunity to expand your business, diagnostics can be a easy way to expand your offerings. The investment in the tools can be significant, but you can start with a high quality manometer like the DM32 and begin doing a basic zonal pressure test, which can give you a lot of data on how the house performs even without investing in a blower door. So it's something that definitely opens you up to be more than your competition if you are willing to begin making an investment in the opportunity to do this type of testing.
Excellent. Well, Steve, thank you for taking the time to join us today. I think this has been a pretty good discussion. I hope it's helped our listeners, and anyone out there that's looking to get more information on this. Retrotec has we have a lot of videos and webinars on our YouTube. Steve also has a large wealth of information on his YouTube channel as well. So go on to YouTube and search for Steve and Rardon. And thanks everybody for your attendance. And Steve, thank you.
Absolutely. Thank you for the opportunity, and we'll look forward to continuing in the future.
Great. Sounds good.